Now let's talk about in-order traversal on our binary search tree. And this in-order traversal is a bit special for binary search tree, and let's see why it is so. Okay, so if you remember the logic for in-order traversal, when we did it previously, the in-order traversal was having this logic. Okay, so if you want to do in-order traversal for a tree starting with a particular node, if the tree is empty, you don't do anything. Otherwise, you first do the in-order traversal of the left subtree, then you do the node specific action, and then you do the in-order traversal of right subtree. So let's try to do the in-order traversal for this tree that we used in our previous example. Okay, so if I do in-order traversal starting with node 100, how it will look like. So the in-order traversal would result in the node starting with 100, right? So I have to do in order traversal starting from node 100. Okay, so the result of this, how will it be? Okay, it will be the in-order traversal of left subtree 100 followed by the in-order traversal of right subtree. Okay, so this output will look something like this. It will be in of left followed by 100 and then in order traversal of the right. However, because this is not just any ordinary binary tree, it's a binary search tree, every value in left is either less than or equal to 100 and every value on right is either greater than or equal to 100. Okay, so what is going to happen is this in-order traversal is going to give us the sorted order of the elements. So let's verify if that is the so. Okay, so in-order traversal starting with node 100 looks like this. Now let's try to do the in-order traversal of the left. This is going to be in-order traversal with subtree rooted at 40. So in-order traversal would be the in-order traversal of left subtree, which is 25, followed by 40, okay, followed by the in-order traversal of the right subtree, which will involve the in-order traversal of left subtree followed by 80. So 60 and then 80. Okay, so 25, 40, 60, 80, and then I have 100. And now let's do the in-order traversal of the right subtree starting with 200. So first I will have to do in-order traversal of the left subtree, which is absent. So then I will have 200. And after that I have to do the in-order traversal of the subtree rooted at 300. And the in-order traversal of this subtree rooted at 300 would involve the in-order traversal of this left subtree 300 followed by 400. So then I will write this 300 and 400 at the end. And now we have to write the in-order traversal of this subtree rooted at 280. This will be 250 followed by 280. So I will have 250 and then 280. And if you notice this in-order traversal sequence, it is the ascending order. Okay, so you have one way of sorting the numbers. Given the numbers, you can build a binary search tree and then perform in-order traversal, and that gives you the sorted order of numbers. It might not be the most efficient way to do it, but still it's a way of sorting your numbers. So now we are getting the numbers in the sorted order. A number that comes, say, after a particular number in our in-order traversal, we'll call this number the successor. A number that comes before us, we'll call that as predecessor. So number which is immediately before given number in the in-order traversal is predecessor, a number which is immediately after its successor. Okay, and we will use this predecessor and successor when we actually delete values from our binary search tree.